I'm starting my session that still some students are pending. They will join later, no problem. So I think my slide is visible from your end.
Yes, sir.
Yes, sir.
Yes, sir.
So okay, so in my last class, I have discussed about different direct measuring methods and indirect measuring method. After that, I will discuss this slide, but all of you told that it is not visible from your end, so I need to rediscuss these portions. Okay, measurement system and its elements. Okay, so what I was discussed in measurement system and its elements means I already told you in my introductory period. I have considered one example. Okay, we're having some means skin having some temperature sensor. Okay, so temperature sensor that sensing the temperature and how it will be managed to remove our hand. Okay, through getting the control pulse, okay, from the controller, control signal from the controller means process unit, and the movement of the so the controller and the actuators, how the movement happened. Okay, muscle movement happened. So same thing happened to our generalized measuring structures, which is given to this slide. You can see that initially you can see there is a physical system. Okay, so physical system means whatever things you have, means it may be speed of the motor. Okay, or it's maybe the temperature, room temperature, whatever physical quantities are there. So it may be the pressure. So you have to pick the sensor. Okay, sensor means what? If you want to measure the pressure, okay, definitely you have to use some pressure sensor. So if you see what is pressure sensor, actually we are using some crystals, like quartz crystals are there. Okay, so if you give some pressure across the quartz crystal, so you can find out some voltage. Okay, so that voltage will come to that voltage will be generated. Okay, and you need to sense that voltage. Okay, so whatever the physical quantities are there, and if you are related to the electrical measurement, so that physical quantity, the signal from the physical quantities should be converted to the physical signal to the electrical signal. That's why which one is important? The transducers. Okay, you know that transducers are there. So what is transducers? Transducer are also an example of a sensor that can convert the physical quantity to the electrical quantity. Okay, means electrical signal. Like you say, I'm telling about the pressure. Okay, so we are using some crystal. So that crystal having some pressure. So if it sends some, means observe some pressure across two side of the crystal, so some potential voltage, means some voltage will be generated or develop across your crystal. Okay, that signal is there, it's converting the pressure to the electrical signal. Another example I can take, so magnetic circuits are there, so Hall effect sensors are there. If there is that Hall effect sensor can convert the magnetic signal to the electrical signal. Okay, that's a Hall effect sensor. Okay, another one is that I have already told you that one is Hall effect sensor and quartz effect. Another one is temperature sensor. Okay, or you say like the tacho generator. Okay, so in tacho generator, what happens? You can convert that RPM to the electrical signal. So all the cases you are converting the physical signal to the electrical signal. Okay, so that only happened in case of transducer. So transducer is an example of a sensor. Okay, but sensor, what happened in case of sensor? Sensor can convert, okay, any of the form of signal to any of the form of signal. Means it may be physical signal to mechanical signal, whatever signals are required, not signals, mechanical response, like that thing. Okay, so it can convert any of the form. So sensor is in superset and transducer is in subset. Okay, so here you can see that, say, primary sensing element. So that primary sensing element means in our body, it told you that skin, the temperature sensors are there that can sense the temperature, and again it will convert to the electrical signal through the transistor. Then signal conditioner is there. So what is the purpose of signal conditioner? So if you see, so that signal is coming from that, means electrical signal is coming, but their magnitude is very less. Okay. Why they are very less? You can understand some pressure is acting across the quartz crystal. So definitely that amount of voltage will be very less. So what you need to do, you have to amplify that value. Okay, so that's why it is called the signal conditioner circuit. Okay, you need to amplification, proper amplification for the measurements. Okay, then what we will see, that variable conversion element. So then that signal conditioner, okay, then that value will be compared with your actual one. Sorry, compared with the reference one. But how to get the reference? So that reference is already given to your processing unit. Okay, so processing unit means any of the circuit. We can use different processors like microcontroller, microprocessor. That in my first class I took an example of human brain. So human brain is a processing unit. It having some reference value. Prefix values are already there. Okay, some reference values are there. So only the changes of that actual signal. So reference values are fixed. Okay, only actual sense value means if the bowel is more very hot. Okay, definitely that error will be more. Okay, you have some reference value. Reference temperature of our body is normally 36 point. It is almost 36 degrees, 98.4 degree Fahrenheit. Okay, so if you change, if you sense the, if your bowel is more than 100 degree Fahrenheit, sorry, more than 100 degree Fahrenheit. So definitely we have to alarm, means how much tolerable band is it. Okay, that will be decided by your processing unit. Okay, then you will get some value. So variable conversion elements. Okay, so some conversion also be required in mathematical calculations. Then manipulations. Okay, manipulation and data transmission. Manipulation means I am talking about the controller. Manipulations means not data manipulator. It's a controller. Controller can, if system having some good controller, so controller having ability to reduce that error. Okay, error means your reference signal minus actual signal. Okay, if your error is positive, means your reference signal is more than of your actual signal. If your error is negative, so your reference signal is less than of your actual signal. Okay, so that error will be there. After that error will be, should be passing through the control structure, controller of the system. So controller try to reduce the error. Okay, and it can feedback to the system. Okay, so then that data will be transmitted through, I told you in my first class that in our body we are using motor neuron for signal, sending the signal from brain to muscles. Okay, then muscles, what is your, it is your actuator. Okay, so who is actuating the value. Okay, so controller send the signal to the actuator, then actuator give the response to the muscle. Okay, so that can remove, okay, give the signal. Okay, so that will actuating the values. Okay, so you can remove your hand from the hot bowel. Okay, so everything is different here, decided here. So you know that important terminologies are indicator and recorder. Okay, indicator means that having only capability to deflecting the pointer, so that is called the indicator. Okay, that is called the indicator, means indicating the values. Okay, what is recorder? Recorder means indicator can all the time what happened, the indicator having data storing capability. Okay, so you can say like that, it's a recorder, it's a recorder. So indicating the signal. Okay, after indications, okay, after indication it is recording the value. Okay, that's why it is called the recorder. Okay, so what are the important points? So input you have measured, okay, and output means what you are getting from that signal. So that is data presentation element. So most important components, I think all of you will to understand. So what is the detail over there? The measurement system may be defined as a systematic arrangement. Okay, so systematic arrangement means, I think all of you will to understand what do you mean by the systematic arrangement. The entire arrangement, okay, for the measurement or the determination of an unknown quantity. Unknown quantity means your actual signals. Okay, initially it is unknown. Okay, so in last class I discussed about taking an example of a potentiometer, means comparison by the standard cell, how to find out that unknown EMF by using the standard cell. I told you that potentiometer normally we are using, how to balance null detections. Okay, so everything happens. So actual value that you need to measure, that is initially unknown. So you have to measure it. Okay, that's why the entire element need to be done. Okay, sorry, need to be arranged. Okay, so analysis of instrumentation. Okay, the generalized measurement system and its different components or elements are shown in the figure. So you can see the important components what are given. So important topics, so that I have already discussed in my own voice. So you have to, when you are preparing the notes, okay, you have to elaborately retain the most important points, like primary sensing unit. What is primary sensing unit? Okay, you can follow any of the standard book and you can prepare your copy. So day to day, all of this my suggestions or advice from my end. So day to day, as per my class schedule, all of you prepare the class notes. Okay, means so prepare your means notes. Okay, any of the day I can ask for the note. So I will give some time and you have to submit to your class here. Okay, then I can collect your notes from the CR. So you should not pending your work. Day to day you please update it. Okay, update in your homework copy. That's final the class. Note down in a class notebook, then make it fair in your homework copy. So you have to prepare the note, class note. Okay, so day to day you should prepare it. So first one is important topic what I have already discussed, the primary sensing element that I discussed. Then variable conversion element, okay, that is variable conversion element. Manipulation element, that's controller that I am telling. Data transmission element, so data is transmitting from in our body we are using what motor neuron, okay, from brain to muscles, how the data is transmitting. So in our measuring instruments, measuring depending upon the sophistication of the instruments, so we have to design that data transmissions, means how efficiently you can transmit the data without having any loss. Then data presentation element, so data presentation element means how would you present it. You are using some storing element, you are having some storing element, so where you are gathering the data, or you are using it by simple methodology, means indicating instruments. Okay, so that points are very important. Next are the stages of the topical measurement system. So that I have been already discussed. So still I am telling again. So what are the important stages? There are mostly three stages are there. Stage 1, stage 2, stage 3. In case of stage 1, what you need to, you can sense. Okay, you can sense the desired input by exclusions for all other and provide the analogous output. So whatever you are sensing over there, sometimes what happens, some similar type of data also been coming, like your hand is just touching with the bowel surface. Okay, so bowel is hot. Okay, so whatever, so not like only temperature, other components also coming, other kind of signal also there are, not like only the heat sensor, temperature sensor, other sensors also be there with your skin, means with our skin, that can also sense the other parameters. Okay, so it is metal bowel or it is plastic bowel, whatever. So that was not sensed by the temperature sensing unit. So that is that is different. Other sensing units are there. So how do you understand touching of the material? You have to understand how it is prepared. Okay, so some learning already there. So all the responses will be coming in the stage 1. Then you have to segregate that one. Okay, means which response you need to be collected and we need to be processed. That will be done in the stage 2. What then what will be the next step? So in stage 2, the modifies the transition signal into form of the usable and by the final stage. Means that I take already told one example. If having that signal strength is very less, so you need to amplify it. If you are not able to amplify it, so you are not able to compare with your reference value. If your sensing value is 0.1 volt and your reference value is 20 volts, so how do you compare them? You are not able to compare them, so both should be in the same range. Okay, means same amplifications are required for comparing that reference value. Okay, equivalent reference value. Okay. Then increases the amplitude and the power of the signal according to the requirement. So you can increase the amplitude, means increase the amplitude level of voltage. Okay, and Definitely, throughout the cases, power are constant, may energy are constant as, well, as per the conservation of the energy. Energy is an integrating unit, means power into time equal to your energy. So energy is constant, means definitely power is constant. Okay, if voltage is changing, varying, definitely current will be varying. Basically, power is constant. That's why amplitude of the voltage, you can say like that, increasing or decreasing of the amplitude of the voltage or the power maybe changes as per your law you have defined by you. Okay, it is defined by you. Selectivity filters unwanted components, convert the signal into the pulse form. So unwanted things should be rectified, means it will be eliminated from the system. So this is for the stage 2. Three steps are there in stage 2. Then final stages, you can come to the final stage. Okay, so final stage provides the indications of the indications of the recording from that can be equivalent by a personnel or the controller easily. So you can, the system may be indicating, okay, or recorded. So if you are design a costly system, so definitely it can record the data for indicating. So only the simple things will be there. Okay, so the pointer will be there that can pointing out that value whatever you are measuring over there, so that you can find out from there. Okay, last one is the recorded the data digitally or the computer if necessary. So it about your complexity of the system and sophisticacy of the system. If you are going to design for cost efficient system, so data storing is not required for those cases as per your budget. Okay, your budget is not so high, so you need not to record all those things. Okay, you can only you can take only those values. Okay, finally sorry, you can only connect on integrate, sorry, indicating meter, so you can note it down by manually in by using pen paper. Okay, if you want to store for the future record, then definitely the recording element are required, recording storage, okay, it's required. So these are the three steps for typical measurement process. Okay, after that the classifications of the instruments, so that is very important. Okay, so I told about you the standardizations. Okay, standardizations of the instrument based on the standardizations. Okay, so in my last class I told about the standardization. Okay, how you are standardize your instrument and how they are means if you are having manufacturing units, so which standard you need to follow. Okay, that was discussed in my previous class. So here I am going to telling about the what are the different classifications, means different types of instruments are there. Okay, so first is that absolute and the secondary instrument. Okay, these two are the major things of the classifications, absolute and secondary instruments. Okay, that is first one. Okay, there are six things are there. Okay, six classifications: absolute and secondary instrument. Next one is analog and the digital instruments. Okay, so analog and digital instrument. Third one is your mechanical, electrical, and electronic instruments. It having some category. I am coming. Next one is the manual and automatic instrument. Next, 5 is self-operated or the power-operated instrument, and finally the deflection and the null output instrument. So based on the application, you can find out or you can categorize the instruments into different forms. Okay, it may be absolute. If it is showing that absolute reading, means absolute reading is most of the standard laboratory you are using it, means whatever means suppose you have some manufacturing unit, so you are procuring some standard instruments from Indian market. Okay, not from the foreign market. Okay, no, sorry, not from the foreign standard giving organization. So what you will do, so you are using it from your directly procure it from the market, and you are design your instrument as per that reading showing by those standard instruments. Okay, for what is absolute standard instruments, means those having designed for the only for the standard labs, means when renowned labs are there, those are purchasing it very costly equipments. Okay, from those are giving the standards from that institutes, they are procuring their instruments. So that is called absolute instruments. So in case of absolute instruments, they are mostly used in standard library laboratories. That I am telling standard standard laboratories. Okay, then
So what are
deflection.
standard laboratories, sir?
Huh?
What do you mean by standard laboratories? Is there any particular
Standard laboratory means national view of laboratories, means whatever India having some standard laboratories, like if you go for measurement of resistance. Okay, if you just take an example, measurement of the resistance. So whatever standards are given, okay, so whatever bridges, normally we are using the bridge circuit from the measurement of resistance. If that bridge circuit is designed by some local made, okay, local made laboratory, so this is secondary standard laboratory. Okay, but we are having the primary standard laboratory or the national or international standard laboratory, means those laboratories thus following those international standard, and they are designing those standard instruments, and you are procuring the instruments from those standard laboratories, means that is more costlier. If it is local market, if your standard equipments you are purchasing from the local market, so definitely it's a standard laboratory, but it is not the primary standard laboratory or the international standard laboratory. It is secondary standard laboratory. So that's the simple thing for the standard laboratories. Okay. Then deflections and the tangent galvanometer, those are the absolute instruments. Means directly you can procure from use as a null detection. Okay, the tangent galvanometer or the deflection meter, that you can also use for the null detections. For the secondary instruments, what are the things are there? So 3 points are very important. Normally 3 types of secondary instrument is observed in our laboratory, means in our cases. So what are the instruments? Indicating instruments. Another one is integrating instruments. Another last one is recording instruments. So what is indicating instrument? Very simple, like pointers are there. If any values are if you connect your instrument to the circuit, so it is pointing out the voltage or the current. So you can say like that it is indicating instrument, or pointing out the energy. Okay, so that is indicating instrument. So ordinary ammeter, so examples are ordinary ammeter, voltmeter, wattmeter, frequency meter, power factor meter, all are the examples of indicating instruments. Another next one is the integrating instruments. Integrating means it is integrated with the time. Okay, so time dependent. Okay, so if the time has changed, so measurement data has been changed. Okay, that's why it is called integrating instruments, like energy meter measuring instruments. Okay, so ampere hour meter is there, that is integrating. Ampere hour normally rating is given in the battery. Okay, so how much ampere hour battery you are connecting for your domestic UPS. Okay, like 200 ampere hour. Okay, or 110 ampere hour, means 80 ampere hour. So whatever 150 ampere hour. So it's an indicating unit. Okay, another one is energy meters. Okay, next one is the recording instruments. So recording instruments normally we are using in our power plant or in single load substations. Okay, substations we are using some recording instruments, like where the forecastings are needed. Okay, means throughout the year how much generations are there, how much load demands are there in the substation. Substations are categorized in different types: generating substation, transmission substation, distribution substation. A distribution substation having another segregations are there. Okay, like your pole mounted substation is in front of your home. So different portions are there, but most of the cases generating substation and transmission substation and distribution substation. These 3 substation normally we are fetching the data. Okay, how much data means power is coming from the feeder. Feeder means in generating substation you can say like that how much generation is there, how much megawatt generations is there, or day to day, time to time, means hour to hour data will be there, and how much demand is there. Okay, so you can predict or you can forecast the value in the next year. Okay, if you have the pattern for last 4-5 years, so you can predict something in your coming year. Okay, next means upcoming year you can predict something. for this duration how much power requirements are there. Okay, so that are important. So recording instruments is related to this one, like curve plotter means all the time it having it plotting the data. Okay, it plotting the curves. Okay, so curve is traced which shows the variation of the magnitude of the electrical quantity. Okay, electrical quantity under observation over a definite period of time. Okay, such instruments are generally used in powerhouse, that I am telling, that substations. Okay, where the current, voltage, power all are maintained within the certain acceptable limit. Okay, if it is beyond that limit, so definitely the chip circuit will be enabled and system will be isolated yourself. Okay, so these are the very common features of the different types of absolute and secondary instruments. Next one is the analog of the digital instruments. Okay, analog or digital instruments means, so you can see over there, so normally we are using analog instruments means the pointer. Okay, the pointer, the deflection of the pointer is visible from your end. Okay, so if the current is passing through the ammeter, so the pointer deflection would be there. So you can easily see that pointer is deflecting. Okay, the pointer is deflecting means current is passing through that through this meter, or the voltmeter is there. So you can also see that voltmeter or pointer is deflecting. So how much potential difference is there, that you can directly measure over there. So it is analog instrument. So analog instrument signals at the analog unit vary in the continuous fashion. Okay, and can take take an infinite number of values in a given range. Fuel gauge, ammeter, voltmeter, wristwatch, speedometer, all are the examples of the analog instruments. And in case of digital instruments, so digital display unit will be there. Okay, so there is a conversions. Okay, so you can fetch the value with the sampling time, means based on the sampling frequency or based on the changing of the sampling frequency, you can fetch the data. Okay, means at that instant how much voltage is there, at that instant how much current is there. So not continuously, you are fetching that value with some discretized manner. That's why it is called digital instruments. Okay, analog instrument is for continuous signal. It will be given by the meter. Meter will be given the reading as per the continuous signal. And digital signal you are getting from the digital instruments. So not signal, you are display directly. You are getting, you can get the data from the display. Okay. So signal varies. Okay, signal varies in discrete steps. Okay, and taking in the finite number of different values in the given range are the digital signals. Okay, and the corresponding instruments are of the digital type. Okay, so those are related to that signal, and the instruments are definitely digital meter. All of the digital instruments have some advantages. Okay, some advantages over the analog meter, in that they have high accuracy, high speed of operation. Okay, it's elimination of the human operational error. Human operational error means sometimes some error is there. If you want to find out that value, if you want to measure that value, some human error may be there. Okay, so that's why some erroneous results sometimes it will come. So it is called perpendicular error. If you are not visible perpendicular to that pointer, so any of the angle is there, so different value will come. Okay, so that gives you some erroneous results. Okay, that's why it is that's why digital instruments are better in that case. Okay, so like digital multimeter. Okay, for example, the digital instrument, so directly you can see it shows the display board. It having some display board, you directly get the reading from the display board. Okay, and other instrumentation also be there, like mechanical instruments, but we are focused about electrical instrumentation. Okay, measurement, electrical measurement and instrumentations. Okay, related to this one, electrical instrument, and some of the portion also been discussed about the electronic instruments. Okay, not all kind of electronic instruments. Some of the electronic instruments also been included in our module. So that portion also been discussed in some in future future classes. Okay, so based on that electronic instrument, the digital instruments are the examples of the electronic instruments. So our main thrust area is that electrical instruments, another one is electronic instruments. Both the instruments, electrical instruments in single word you can say like that, analog type of instruments, and electronic instruments is most, you say like that, the digital instruments. Okay, and you can easily get it, and that will be discussed. Okay, so manual and automatic instruments. Okay, so measurement of the temperature by a resistance thermistor incorporating in the Houston bridge. It's an example. Okay, manual or automatic instrument means manually you have to read out the value. Means the pointer is deflecting, you are getting the reading, take the reading. You take the reading, so you can say like the manual one. Okay, and automatic means automatically the reading will be taken by the instrument. So what are the different classifications? That is different. Self-operated and power-operated instruments. So self-operated means electromechanical instruments. Okay, the electromechanical means whatever they it take participate, means whatever elements are there, means functions, means it's a current is passing through the circuit. Okay, current take part for measuring purpose. Okay, current and voltage. Okay, that power operated, that's why it is called the power operated instruments. Okay, so power operated instruments means directly the instruments means give the reading directly current and voltage. Okay, they are passing through that one and you are getting the reading. That's a power operated. And self operated means it is not depending upon any of the components, directly it can measure it. Okay, so that is self operated. So deflection and the null output instruments, another deflection, another instruments also be there. In my last class I discussed like in null operated instruments means only this is used for only the standardization. Okay, if your instrument or if your component is standardized, like you are trying to find out the unknown voltage of a standard cell, sorry, unknown voltage of a cell, and you having some standard cell means you know the reading of the cell, means battery. Okay, now you are trying to find out some unknown the reading of the or the values of the unknown cell. So you have to use some potentiometer circuit, means balancing that one. So how do you see that both of the voltage are same? So potentiometer or null detectors is connected in between both of the sources, one standard source, another one is unknown source. Okay, if both the potential is same, so in the deflector there will be no current flowing through the deflector or the null detector. So you can say like that there is no deflection of the null pointer. So your system gives the best one. Your system gives the value of the unknown sources or unknown cell with the having of the standard cell value. Okay, that we will directly get from there. Okay, another one is deflection. So that both are related. First deflection, if positive side deflection, so there is some error. Means still some point need to be go. If negative side, so your standard value is more than of your measured one. Okay, so any of the error will be there, so deflection is there. And null detection means it stands still in the zero. Okay, in that case, that zero will be midpoint. There is a left side. There in left side some negative point will be there. Right side some positive point will be there. Based on it you can deflect. Based on it you can detect. One minute. Okay, so I hope all of you can understand. So what is deflection? Okay, so deflecting instruments and the null detection. Okay, so normally mechanical displacements are there for the pointer, and permanent magnet moving coil means PMMCs are there for the deflection purpose. Okay, so based on that current is flowing through the PMMC means that I discussed in my electromechanical devices. Okay, that next to next class. So that portion is related to current flowing through this path means electromagnets will be there and pointer is connected to the electromagnets. Okay, not electromagnets means that is called that aluminum free. Okay, that directly connected over there, so pointer is deflecting. Okay, so moving iron element, those are the examples for the deflections and the null output instruments. Okay, so from here we can see that I think how much time is there, I need to take the attendance. Okay, almost over. Okay, so okay, so that portion I have discussed today. So next portion I will discuss in my next class. Okay, next class that chapter module will be completed means first module I think so. Okay, so if you have any kind of doubts you can ask me. In my next class one discussion session will be there. Okay, so all of you be ready for that. If you have any doubt you can ask me related to this chapter. Okay.